Okay, here we're going to talk about the mole and the Avogadro constant. It's kind of a logical place, it would seem a logical place to start the mole topic, talking about this, but usually if you do start at this place, it can cause confusion. So maybe come back to it a bit later. Right, now, so what I've got here is what scientists knew, like by about 1850, the time of Mendeleev's periodic table, scientists had this idea of relative atomic mass. Okay, so I'll pull that. Where's it gone? Relative atomic mass. Now, relative means in comparison to other things. So they didn't know how heavy these atoms were. They had absolutely no idea, but they did know that hydrogen was the lightest, and he gave that a relative atomic mass of 1. Say that was 1. Then they knew that carbon was about 12 times heavier than that. Okay, and they knew that magnesium was about 24 times heavier than hydrogen. In other words, about twice as heavy as carbon. They knew that sulfur was about 32 times as heavy as hydrogen. Okay, and then this idea was expanded away from atoms for this idea of relative molecular mass. And so you could say, here I've got an H2O molecule, and the oxygen weighs 16 times heavier than hydrogen. Each hydrogen weighs 1, so that's got a relative molecular mass of 18. So that means a water molecule is 18 times heavier than a hydrogen atom, or it's 2/3 as heavy as a magnesium. Sorry, that's 3/4, isn't it? Or 3/4 as heavy as a magnesium atom. So you get the idea. Relative is the key word, everything compared to another thing. You may think, how on earth did they know this? And you don't need to know, but it is quite interesting how they did this. Had no idea how big the atoms were. They could compare them by doing these sorts of experiments. So look, if you get magnesium and you burn magnesium, you make magnesium oxide. So if you get 5 grams of magnesium, you'll make 8.3 grams of magnesium oxide. But they knew if you did the same with calcium, even though it's got the same formula, like 1 calcium to 1 oxygen, you'd only get 7 grams. So that means proportionally, the calcium atom must be heavier than the magnesium atom. And then if you did it with the zinc, 5 grams of zinc, formula again ZNO, but you get even less oxide, 6.2 grams. And it's because proportionally the zinc atom is bigger. All right. So by comparing all those, they came up with this idea of relative atomic mass. And as I say, you don't actually need to know that, but that's how they did it, by doing those sort of experiments. Right. So here we got relative atomic mass. We know carbon is 12 times heavier than hydrogen and so on. So if you expand that idea, then if you had 1 gram of hydrogen, because it's only a 12th as heavy as carbon, if you had 1 gram of it, to have the same number of atoms, you'd actually need 12 grams of carbon. And to have the same number of magnesium atoms as you got in 1 gram of hydrogen, you'd need 24 grams of it. And likewise for sulfur, you need 32 grams. And then you can say for water, well, to have the same number of water molecules as you have as you have atoms in hydrogen, you need 18 grams. Okay, so this is where this idea of a mole came about. So a mole, as you probably know, the definition of a 1 mole is the amount, it's the atomic mass of an element expressed in grams. And the reason why they do that, because they know they all, the 1 mole of anything, they all contain the same number of atoms. Okay, now how many atoms are there? At first, no one had an idea, and it took, I think at the turn of the century, like 50 or 60 years later, before people came up with a reasonable estimation. And now we know that the number is about, and people have actually determined it very accurately, but the number we usually stick with, it's called the Avogadro Constant. That's an Italian scientist, or the Avogadro Constant, or sometimes the number. and it is 6.02 times 10 to the 23. So that's the number of atoms in a mole. Of an element. Or if it's a compound you're talking about, it's the number of molecules in 1 mole. Okay, so for example, 12 grams of carbon, that contains 6.02 times 10 to the 23 carbon atoms. Whereas if you have 18 grams of water, you've got 6.2 times 10 to the 23 molecules of water. And slightly confusingly, you have got, because there's 3 atoms in 1 molecule of water, the number of atoms you've got in there, get rid of that, sorry. The number of atoms in 1 mole of water is equal to 3. So about 18. 3 times 6.02 times 10 to the 23. So that's what the mole and the Avogadro constant are all about.